Hey everyone, so this is another video for section 6.2, and in this video we're putting together everything that we've been learning in 6.2. So we're going to look at these examples and apply the properties that we have just been going over this week. So apply all of these laws of exponents to simplify more expressions, okay? So let's get started. It says in problem 4, we're going to use the product of powers and quotient of powers property to simplify the expressions below. So remember, product of powers, when we see that we are multiplying variables or multiplying common terms, we add the exponents. So 3 squared times 3 to the 6th is going to give me 3 to the 8th because I'm adding my exponents. We can do 3 to the 8th in a calculator, and we're going to get 6,561 as our answer. Okay, let's check out B. We're multiplying two terms here, so we have to watch out for adding our exponents. So we're going to go for like terms first. 3 times -2, I can do that, right? 3 times -2 is -6. The next like terms I'm going to look at are those a's. A to the 5th, and we can write it on the side here, a to the 5th times a. Remember, if you don't see an exponent, it's 1. Multiplying variables, add the exponent, so that's going to be a to the 6th. And then let's check out the b's. I've got b cubed times b to the 7th, multiplying variables, add the exponents. And I got b to the 10th. That's going to be my final answer. Okay, let's check out C. I've got -4 squared divided by -4 to the 7th. Remember, when we are dividing variables, we subtract the exponents. So I'm going to have -4 to the 2 minus 7. That gives me -4 to the -5th. Remember, if I have a negative exponent, we can move it to the denominator and make it positive. So I'm going to have 1 over -4 to the 5th. I'm allowed to have negative numbers. The -4 is not a problem. And then we're going to have, right into a calculator, 4 to the -4 to the 5th. Let's do that. -4 to the 5th is going to give me 1 over -1024. Okay. And then let's check out D. Again, we're going to look for our like term. So I've got x to the 4th. I'm going to leave that for now. So we're going to have x to the 4th. Y squared is fine. Z is fine. Let's see, x to the 0. I know that's just 1. I'm not even going to really write it. And y squared to the -2 has a negative exponent in the denominator. I'm going to move it to the numerator to make it positive. And so I really don't have anything in my denominator, so I'll really get rid of my denominator. Combine any other terms. I've got x to the 4th. Notice I've got y's here. Y squared times y squared gives me y to the 4th. And z, has no like terms, so we're going to leave it as z. Okay, let's check out problem 5. We've got power of a power. Power of a power, we multiply the exponent. So x squared to the 4th gives me x to the 8th. X cubed to the -3rd gives me x to the -9th. I have a negative exponent, move it to the denominator to make it positive. Let's check out problem 6. Power of a power property. When we have a product going on, that means we distribute our exponent when we have a product inside parentheses. So I've got, notice that I've got -2 to the 4th times x squared times 4. Multiply our exponents because it's power of a power. -2 to the 4th, we can do that. -2, and I'll write it out to show you that you can do it too. -2 times -2, 4. -2 times -2, 4. 4 times 4, 16. So I've got 16. X to the 2 times 4 is x to the 8. Let's check out B. We're going to distribute, so I've got x to the 3 times 2 over y squared. I got x to the 6th over y squared. Let's check out C. We'll distribute, so I'm going to have x to the negative 3, y to the 6th, right? Power to a power, just multiply, and product in there, so we distribute it. And then D, we have, when I look at D, I see I have a negative exponent. And I don't like that negative exponent. Let's distribute it in, and we know what to do with that negative exponent. I've got 3 to the negative 2, x to the negative 2. Both of these have negative exponents. Both of these terms get moved to the denominator. So I get 3 squared x squared gives me 1 over 9x squared. Okay, let's check out problem 7. Very similar, we just want to make sure we rewrite these only having positive exponents. So A, we've got to distribute that negative 2 to all of the other powers. So I've got x to the 4th. That's kind of cool, right? Negative times a negative gives me positive. Don't need to move it anywhere. Y to the 6th. That one wasn't too bad. Let's check out B. So much going on. Look for like terms to start, and I'm gonna color code this, so hopefully it'll help. Just looking at my numbers, I've got 4 times 2, that's 8. Let's go for whatever term is next. My x cubed and my x to the 4th. Multiply variables, add the exponents. So I've got x to the 7th. Let's check out the next variable, y to the negative 2 times y to the 1 first power. Multiply variables, add the exponents. I've got y negative 2 plus 1 gives me negative 1. And we can just write that as negative 1 for now. We know what that's going to end up being. And then I've just got the z to the 0 power at the end. We know z to the 0 power, anything raised to the 0 power is just 1. And the best way for us to simplify this, we've got 8x to the 7th over y to the first power gets moved to the denominator because of the negative exponent. And then C, let's check out C. Let's look for our like terms. So I've got negative 6 divided by 2. So I've got negative 3. I'm going to start to make a fraction here. I've got x cubed. Let's get a different color. X cubed divided by x to the 6th. Divide variables, subtract your exponents. So I've got x to the negative 3, make it positive, move it to the denominator. And then I've got y squared divided by y to the negative 1. Divide exponents, divide variables, subtract the exponents. So I've got 2 minus negative 1 gives me a 3y cubed. So I get a y cubed. Okay. So those are some examples. Let's keep going here. And I want to check out problem 8. So problem 8 is very similar. I just want us to walk through and be able to explain these steps. So it says simplify the expressions below, justify each step. Very first thing when I look at A, I've got 3 squared. I know 3 squared, right? 3 squared is 9. That's all I'm going to do so far. One step at a time. And so my justification is exponent definition. Because that is the definition of an exponent. It tells you how many of a number to multiply by itself. Then I'm going to look at this expression and I see x to the 0. Well, I know x to the 0 is 1. That's the next thing I'm going to do. And that's the 0 exponent property. Now, when I look at this, I can do 9 times 1. That gives me 9 times y to the negative 2. That's just multiplication. And now I have to handle that -2 exponent. So I move it to the denominator and make it positive, and that is the negative exponent property. Okay, so this is called a proof. What we're doing here is we list the math on the left and then an explanation on the right. And this is something you'll do in geometry a lot, but it's good to see this kind of table in Algebra 1. Okay, let's check out B. So I'm going to go through, just like we've been starting, go through, look at my like terms. Let's combine my numbers. So I've got 3 times 5 times -2. 3 times 5 is 15. 15 times -2 is -30. And so we're going to leave everything else. V to the -9, V to the -3. All we did was multiplication. And now we can combine those variables because I only have one variable. So I've got -9, V to the -9 times V to the -3. I have an exponent of 1. Multiplying variables, add the exponents. So I've got -9 plus 1 is -8. -8 plus -3 is -11. And that is the product of powers. Property. One last thing, we have to take care of that negative exponent. So I've got -30 divided by V to the 11th is the negative exponent property. Okay. All right, one last thing for us to talk about is scientific notation. We haven't talked about scientific notation in a while. So when we look at scientific notation, we're looking at like terms again. So we're going to multiply. We have 4.2 times 2.5. So I'm going to get 4.2 times 2.5. That gives me 10.5 times 10. This part right here, again, multiply variables, add the exponents. I'm going to get 10 to the 7th. When we're writing in scientific notation, we have to only have like something in the 10th place here, so it only has to go over 1. So if I have to move this decimal to the left, that's going to become 1.05 times 10 to the 8th because I moved it to the left. And here's my final answer. Let's check out C, very similar. I'm going to multiply my numbers in the front. 1.1 times 8 gives me 8.8 times 10. I'm going to notice I'm multiplying variables, add the exponents. It's going to give me 5. It's already in that 10th place, so we're good. And now we're going to check out B and D. Super similar. We're dividing scientific notation numbers, so we're going to divide our numbers. 5 divided by 2 is 10.5 times 10. Dividing variables, subtract the exponents, we get -4. And then D, 4.5 divided by 1.5 is going to give me 0.3 times 10. -4 minus -5. -4 minus -5 is going to give me 1. Okay, and so I need to make sure I have a number in that 10th place, that first place, so I have to move it to the right. So I'm going to get 3 times 10 to the 0, because then I'll have a decimal right there. Okay, and then the last one here, in a science experiment, a scientist records the wavelengths of 6 waves. The wavelengths in nanometers are listed below. Which 2 wavelengths are equal to one another? So let's get these all in the same form. Let's get these all written in scientific notation. So this one is already written in scientific notation. Amazing. Let's look at the one to the left. So notice I've got 1/1000th. So I know that's 0.001. I've got tenths, hundred, thousandths. So that means in scientific notation, I have to move this 1, 2, 3 places to the right. So I get 1 times 10 to the -3. And then this next one, I've got 1 times 10. Oh, let me erase this. I've got this number 1.0001 times 10 to the first power. It's already fine. Then I've got 1 times 10 to the negative 3. I have to move that decimal place because it's a tenth. 5 100ths, so that's 0.05. Move it 2 places to the right. So I've got 5 times 10 to the negative 2 for scientific notation. And then one more, I've got 1, 2, 3, 4 places to the right times 10 to the negative 4th power because we move to the right. So looking at these, which ones are equal? We can tell this one is equal to this one, 10 to the negative 3 and 1 over 1,000ths are equal. So scientific notation helps us compare numbers a lot more than all these different forms. Decimal, scientific notation, a fraction, negative exponent. Which wavelength is the shortest? Which wavelength is the longest? So our shortest one is going to be the one with our, notice here, our smallest exponent. So I've got 1 times 10 to the negative 4th is the shortest. And then what's the longest is the one with our positive exponent. That's this one. 1.0001 is the longest. Okay, so great job, guys, practicing how to simplify and rewrite expressions using the properties of exponents. If you have any questions, make sure you let me know. Great job, guys.